In this video, I will walk you through free response question number 1 from the 2008 AP Calculus exam. This problem is mostly about how to find the area between two curves and how to find the volume of a solid that is sitting on an area between two curves. This problem is calculator active, so we will be using our graphing calculator as needed. Let R be the region bounded by the graphs of y equals sine pi x and y equals x to the third power minus 4x as shown in the figure above. For part A, we will find the area of region R. You can find the area between two curves by integrating with respect to x if you integrate the top function minus the bottom function. In this case, the top function is the sine of pi x, and the bottom function is x to the third power minus 4x. The region R goes from 0 to 2, so these are the limits of integration. Let's enter sine of pi x into the calculator as y1, and let's enter the cubic function into the graphing calculator as y2. So just hit y equals and type them in. We can use our graphing calculator to evaluate this expression. Just remember we are integrating from 0 to 2 and we are integrating y1 minus y2. So let's quit our way out of here. Second, quit. To integrate, hit the math button and choose option 9. We are integrating from 0 to 2. Now we want y1 minus y2. To access y1, hit the vars button, switch over to the vars menu, hit enter, and choose y1. And then do minus, and now we want y2. So do the same thing, vars, yvars, function, just choose y2 this time. And put your dx. So the answer is 4. And that's it. The area of R is 4. Part B, the horizontal line y equals -2 splits region R into two parts. Write but do not evaluate an integral expression for the area of the part of R that is below the horizontal line. So here's the horizontal line at y equals -2, and here's the part of region R that is below that line. Just like we did in part A, we can find the area between the purple function and the green function by integrating with respect to x. All we have to do is integrate the top function minus the bottom function. In this case, the top function is simply -2, and the bottom function is x to the third power minus 4x. Don't forget that we have typed this function into y2 on the calculator. In order to finish setting up the integral, we need the limits of integration. So we need to know the x-coordinates of the intersection points between the green curve and the purple line. Let's enter this new function y equals -2 as y3. So -2. I'd like to graph this on my calculator now, but first I need to adjust the window. So looking back at what was given to us, I see that the x values are between 0 and 2, and the y values are between -3 and 1. So hit the window button. Let's let x min be 0, and x max will be 2. Similarly, we will let y min be -3, and y max will be 1. Let's hit graph and see what we've got. Now we want to find the x-coordinate of the intersection point between the pink line and the green line. So we will hit second trace and choose option 5 for intersection. Right now it's on the red line. We don't want to find anything about that. So hit the down arrow key and that'll switch it to one of the other functions. Go ahead and move your pointer close to the point of intersection and hit enter. And then for second curve, make sure you're not on the red line. We're on the pink line, so that's good. Hit enter. And just leave it here for the guess. So the intersection point is x equals 0.539. I would like to store this into a letter on my calculator. So hit second quit, and then type x and hit the store button. I would like to store this into letter A. So I'm going to hit alpha A and enter. That way, when we use this value later, it will actually use all of these decimals without us having to type them all in. For the AP graders, record that A is equal to 0.539. Let's find the second intersection point by hitting second trace again, and again its intersection. Notice again that it's defaulting to the red function. We just want the green and the pink. So use the down arrow key. Now we're on the green function. Move the pointer over close to the second intersection point and hit enter. Make sure that you're not on the red. We're on the pink, so that's fine. Hit enter. And then just hit enter again for the guess. So this intersection point is x equals 1.675. Let's store this into letter B. So second quit, and we'll say x store alpha B. And there it is. You can show this in your work by writing B equals 1.675. Then you can just put A and B as your limits of integration. This is actually the final answer to part B because they said write but do not evaluate an integral expression for the area of the part of R below the horizontal line. And that's what we have here. But I am going to go on and show you how to evaluate it on your calculator, just in case you need that for a future problem. And now we can type this into our calculator to evaluate. Just remember that the second function is y2. So we can just integrate from a to b and do -2 minus y2. Back to the calculator. To integrate, hit Math and choose option 9. We are integrating from A to B. So hit alpha A and then alpha B. We are integrating the function -2 and then minus y2. For y2, hit the vars button, switch over to y-vars, hit enter for function, and choose y2. And then dx. And that's it, 0.811. So the area of the part of R below y equals -2 is 0.811. Part C, the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of this solid. When they talk about a solid with region R for a base, I want you to picture a really weird loaf of bread that is sitting on top of region R. In other words, the footprint of this strange loaf of bread is region R, and we are looking down from above. When they talk about cross-sections perpendicular to the x-axis, they are talking about vertical slices like this one. Finding the volume of a solid sitting on a region is a three-step process. Step 1 is to find an expression for the base of a single slice. Step 2 is to find an expression for the area of a single slice. And then step 3 is to find the volume by integrating the area. Step 1 is to find an expression for the length of the base of a single slice. When the slice is going up and down like this, you can find an expression for the base by subtracting the top function minus the bottom function. So in this case, that will be sine of pi x, that's the top function, minus x to the third power minus 4x. That's the bottom function. Make sure you include the parentheses. Step 2 is to come up with an expression for the area of a single slice. We are looking down at the top of this solid, sort of like looking at the top of a loaf of bread. But if you take out a single slice, we are told that each slice is a square. So we are talking about a square with base b. An expression for the area of the slice will then be b squared. So now we need to apply that to our expression down below. Right now, this is an expression for the base of a single slice. How can I transform this into an expression for the area? Well, the area, in this case, is the base squared. So I can just take my expression for the base and square it, and now it's an expression for the area. The last step is to find an expression for the volume of the solid by integrating the area. When you integrate the area, you are adding up all of the slices from left to right. And when you add up all of the slices, you get volume. So this right now is an expression for the area. We can turn it into an expression for volume by integrating. All we need are the limits of integration. From left to right, region R goes from 0 to 2. So those are the limits of integration. Now that we have an expression for the volume of the solid, we can type this into the calculator to evaluate. Just remember that sine of pi x has been entered into the calculator as y1, and x to the third power minus 4x is y2. So when we type it into the calculator, it will look like this. So let's integrate from 0 to 2, hit the math button, and choose option 9 for integration, and type in 0 and then 2. We need to square whatever we type in next, so we're going to need some parentheses so we can square this expression later. As I mentioned before, we need y1 minus y2. So I'm going to do vars, yvars, enter, and choose y1, and then minus. Repeat, vars, yvars, function. This time I will choose y2. So here's y1 minus y2, but I need to square this. So I will close the parentheses and square it. And now I just need to put my dx, and I'm done. So the volume of the solid is 9.978. Part D. The region R models the surface of a small pond. At all points in R, at a distance x from the y-axis, the depth of the water is given by h of x equals 3 minus x. Find the volume of the water in the pond. This problem is almost identical to the problem that we just did in part C. Instead of picturing this as a loaf of bread sitting on top of region R, we can now visualize this as a lake sitting below the surface of region R. We are still going to do the three-step process for finding the volume, but instead of taking slices of bread, slices of a solid, we are taking slices of this lake, which is a little bit harder to picture, but that's what we're doing. When they mention all points at a distance x from the y-axis, then you need to picture a vertical line, because if I draw a vertical line like this, then this is the set of all of the points that are that same distance from the y-axis. All right, every point on this vertical line is x units away from the y-axis. So finding the volume of this lake is the same as finding the volume of a solid. Step 1 is to find an expression for the base of a single slice. I know it's hard to picture a slice of lake, but you can do it. So this blue line is one slice of a lake. If we want to find an expression for the length of this slice, we can just subtract the top function minus the bottom function. In this case, the top function is sine of pi x, and the bottom function is x to the third power minus 4x. So this is an expression for the base of a single slice. Step 2 is to come up with an expression for the area of a single slice. The trick is to understand that each slice of lake is actually a rectangle. I've drawn the base B of one slice of lake across the top because this is supposed to be like the surface of the lake that we are picturing. But the depth, the bottom of each slice of lake, is also horizontal. It's a constant. That's because at a given distance x from the y-axis, the depth of the lake all along this position is the same. It's given by this function h of x. So for example, imagine that you were 1 unit away from the y-axis. Then at that position, the depth of the lake would be h at 1, which would be 3 minus 1, which would equal 2. So that would mean that the entire bottom of that slice would be at a depth of 2 units. Once you realize that each slice of lake is a rectangle, it's easy to come up with an expression for the area. The area of a rectangle is the base times the height, and the height of each slice of lake is given by this function, 3 minus x. So, an expression for the area will be base times height. In other words, base times 3 minus x. So, getting back to our main expression, right now we are looking at an expression for the base of a single slice of lake. We need to transform this into an expression for the area of a single slice of lake. So area is base times 3 minus x. So we need to take our expression for the base and multiply it times 3 minus x. So now we have an expression for the area of a single slice. The last step is to turn it into an expression for the volume by integrating the area. When you integrate the area, you are adding up all of the slices, and that gives you the volume. So I simply need to take my expression for the area and integrate. What are the limits of integration? Well, this region from left to right goes from 0 to 2. So those are the limits of integration. We can type this expression into the calculator to find the volume. Just remember, once again, sine of pi x has been entered into the calculator as y1, and x to the third power minus 4x is y2. So when we type this into the calculator, it's going to look like this. To integrate, hit the math button and choose option 9. We are integrating from 0 to 2. And we are going to multiply two expressions together. So I'm going to need some parentheses in here. And inside of the first set of parentheses, I'm going to put my y1 minus y2. For y1, I do the vars button, yvars, hit enter, and choose y1. Hit minus and do it again. Vars, yvars, function, this time choose y2. Close the parentheses. Now I need to multiply this by 3 minus x. And close the parentheses again. Finally, type your dx, and hit enter. And that's it. On the AP exam, your answers must be accurate to 3 decimal places, but you are allowed to either round, which would be 8.370, or you can truncate, which means you can just cut off your answer at 8.369. You will get full credit for either answer. So the volume of the pond is 8.370.